Let's try to factor x squared minus 4x minus 45. So the first thing I look for is anything common all the way through, and I don't see any common factors. No numbers, x, no x. So let's start by writing our two sets of parentheses, anticipating we can do this. And we'll start with an x and an x, right? The first and the first, that'll give us x squared. And now, because this leading coefficient is a 1, what we can do is look for two numbers that multiply together to give 45, but add together to give that 4. So let's see. Here's what I think I'm going to do. I'm going to look at that 45, and I can write that as 45 times 1, or 15 and 3, or even 9 and 5. Now, the 9 and 5 looks good because there's a difference of 4 there. So why don't we do this? Let's put in a 9 and a 5, and the order doesn't matter. And because this 45 is negative, the 9 and the 5 have to have opposite signs, right? Opposite signs will give you a negative. And I'm going to put this middle negative sign with the larger of the two products. And the way I wrote mine, the inner product is 9x, the outer product is only 5x. So that inner product is larger than the outer product. So I'm going to put the minus here, minus 9x plus 5x, and that'll give us the minus 4x. So I'm going to conclude now that that is the correct factored form. Let's go on to number 41. We're asked to factor this trinomial, and there's nothing common all the way through. So let's start by writing our two sets of parentheses, anticipating we can do this. So this will give us a y and a y. Now this 48, because this leading coefficient is 1, I'm going to look for two numbers that multiply to give me 48, but add to give me 12. So let's try this. This 48, we can get a 48 and a 1. Now that's not really going to help, because if I add these together, I get 49. If I subtract them, I get 47. That's not anywhere near the 12. So let's keep going here. Now also, because this is even, I'm going to cut it in half and double this one. That'll keep me up to the 48. So let's try this. This will be 24 and 2. Now that's still not going to work. I can't get a 12 out of that, right? If I add them, I get 26. That's not 12. If I subtract them, I get 22. That's not 12. So let's keep going. 24 is even again, so I'll cut it in half. 12 and 4 and double. Now 12 and 4, if I add, I get 16. If I subtract, I get 8. That's not going to help. We're still at an even number 12, so cut in half. 6 and double and 8. Okay, that's not going to help. 6 and 8 is 14, or 2 if I add or subtract. Still even, cut in half and double. How about 3 and 16? Well, 3 and 16, that gives me 19 or 13. You know, I think I've got all of these factors of that 48, at least that I can think of. So I don't see any here, any in this list that are going to give us this 12. So I'm going to claim now that this is prime. In 45, we're going to try to factor this trinomial. Now notice what we have here is we've got variables all the way through. In our first two, back here, we didn't have a variable here, and we had no variable here in the last term. But now in this third term, we do have a variable. So this is not going to be a problem. We're just going to have to get something that gives us a d squared. So first of all, I don't see any common factor, right? I got a w, but no w. I got a d and no d, so there's nothing common all the way through. So let's start by writing our two sets of parentheses, anticipating we can factor this. And we're looking for this w squared, so let's start here with w and w. And now, to get this 11d squared, let's look at this. What we could do is we could write this as 11d and d, and that's it, right? 11's prime, so that's, if this is going to work, this is our only chance here. So let's come back here and write 11d and d, and sure enough, you know, out of an 11 and a 1, we can get a 12 if we add them together. This sign of that last term is positive. So these two terms have to have the same sign, and that's going to be that middle plus sign. So what we're going to have here is w plus 11d, w plus d. And let's just run a quick check on this. Let's look at this. So we'll get w times w, there's a w squared. The outer product gives us plus, right? Positive w times positive d is plus wd. The inner product here, positive 11d times positive w is plus 11wd, and the last gives us plus 11d squared. These two terms here are going to add, so we're going to get w squared plus 12wd plus 11d squared, and that's what we're looking for. So we've got the correct factorization. So let's just summarize it now. So this is going to factor as w plus 11d and w plus d. Or, if you like, you could have written this as w plus d, w plus 11d, because multiplication is commutative. Okay, in number 47, we're going to factor this trinomial. Now look at this one here and compare it to this one up here. The only difference here is that instead of w's, we've got a's. Instead of d's, we've got z's. This is going to factor just probably the same way. So let's write this. We're going to have two sets of parentheses, and let's go with a and a. The factors of this 11 out here, 11 and 1, but we've got to carry that z along. So how about 11z and a 1z? 11's positive, so they're going to have the same sign. It's going to be that middle plus sign. So we're going to have a plus 11z, a plus z. And you can check it. A squared, az, 11az, that's 12az, and 11z squared. So let's conclude here by writing a plus 11z and a plus z as our factored form.